Welcome back to Project X. Today what we're going to be focusing on is the cylinder head itself. The cylinder head has a lot of different parts, and we're going to show you how to install new springs and new valves themselves. We're also going to show you how to lap them in, and you'll understand what that means once we get going along a little bit. We're also going to show you how to check the cylinder head for flatness as well. Just in case it was overheated, we want to make sure that everything is within specifications before I disassemble it and install all these new parts. So right now I have the cylinder head here in place. Even though I have new parts that I'm going to be putting on, new cams and everything, I still like to keep everything in order. That's especially important if you're going to reuse the cams, if you're going to reuse some springs. If you're going to do any of that, everything needs to go back the way it was. So I still have everything really nicely laid out in the way that it came apart. So I know exactly how it goes together when I do this. I'm going to check the cylinder head for flatness, and we're going to show you how to do that. But before I turn that over, I want to remove my cylinder head valve lifters that are sitting on top of the valve springs themselves, because once I turn them over, they could fall out because there's really nothing holding them in place right now other than gravity. So I'm going to remove those, and again, I'm reusing these, so I'm going to put them back in the exact same position they were. Even though I'm getting a new camshaft and new valves and new springs, I still am in the habit, as should you, to keep everything in the original position it was when it came out of the engine. It's very important for an engine. So we're going to take those out and keep them in order of where they go. I know that this is my intake and this is my exhaust side of my valves. And I have my cams here accordingly, so I know which one they're going to go in when I'm all done assembling this entire cylinder head. So I'm going to remove those to start with. And you'll see a magnet does a real nice job of trying to reach in there when they're a little oily. And I don't want to use pliers to pull these out, so I'm just using a magnet to go ahead and remove those from the top of the actual valve springs themselves. Now that we've got those out of the way, I'm going to turn the cylinder head over and show you how to check the flatness of it to make sure that it's within specifications. So you'll notice I've taken the liberty to already clean the cylinder head of any remnants of the old head gasket. That's very important, and don't use anything too abrasive when you do this. We're not wanting to remove metal. The only thing you're wanting to do is just clean the surface of the old head gasket remnants that were there so that you're not having anything interfere with your actual measurement of the actual cylinder head itself. So I went ahead and removed that right now and cleaned it all up, saving you the hassle of watching me clean that. And again, just use something nice and soft. We don't need to remove metal, so choose carefully on what you're going to use to clean this. Doesn't take a lot to remove any of that excess head gasket material. So now that that's all clean, what I'm going to use is a straight edge. This is a precision machining tool that we use to check the cylinder head for flatness. And by that, I don't want the cylinder head to have any dips in it. This needs to be perfectly straight, or it'll affect the clamping on the head gasket itself, which could result in some performance issues and possibly some catastrophic problems later down the road. So this is what we use to check those surfaces. What we're going to do is we're going to go from corner to corner here. I'm going to set it right on the cylinder head and make sure it's flat, which it is. And you'll see I use the machine surface area. There's a non-machine and there's a machine surface. I use the machine side. And I'm going to set this corner to corner on this cylinder head, paying particular attention to the middle. This is your weakest spot on a 4-cylinder engine, is the middle of this head here. And what can happen is if the engine was overheated or anything like that, where you got too hot, you have a chance of warping the head. And what that does is it creates a valley. And what we're going to check right now is to make sure that that's within specification. So I've got my straight edge in place. I'm going to grab a feeler gauge now. A feeler gauge is going to be a very important part of your engine building kits. And right now what I want to make sure is that I can't get the specified size that's too much underneath here. Yamaha says 0.0039 is your maximum allowed warpage on this head. So I want to get the appropriate feeler gauge out of my kit here and make sure that I can't slide it underneath, it anywhere underneath. So you're gonna take your feeler gauge and we're gonna try and see how I'm trying to get it underneath here. And again, pay particular attention right here. That was usually my weakest spot. If at any point you can get this to slide underneath there, then what you have is a possible problem that you're gonna have to have a machine shop handle. And they have a milling process that they can do to remove a small amount of material to essentially true it up. You wanna make sure that your deck and your cylinder block are straight before you reassemble this. But right now, this is great. Everything's within specification, so now I'm gonna flip it over and I'm gonna check it on the other axis as well. Everything's great. This cylinder head is true and able to be used as is without having to send it to a machine shop. That means I'm gonna be able to continue on with removing the valves and the valve springs. We're ready to go ahead and start removing the valves and the valve springs from the cylinder head itself. This procedure is going to require the use of a special tool, and that's a valve spring compressor. We're going to go ahead and compress the spring, which will allow us access to the keepers, which retain the spring and everything all in one assembly. We're going to compress that spring down, take them out, and you'll see how that's done as well using a spring compressor. I have one side of the tool on the actual valve itself, and then this side is going to screw down, compress the spring, which will allow me to access the keepers to remove them. The keepers are relatively small. The use of a small magnet really is helpful in here to get these. And here's one of them. And there's two that hold this on here. And they're kind of cone shaped. So they wrap around the top of the actual valve itself and lock it into place. And we are reusing those, so make sure you keep a track of those. Now that you have that, you can release your valve spring compressor. Once the tension's off that, I can go ahead and remove my valve spring. And now I have access to the valve itself, and I can slide that out as well. We are going to be replacing the actual valves themselves. So we're going to replace the valves, and we've also got new springs in my SBT cylinder head rebuild kit. It did not come with new keepers, so make sure you keep track of those. And for illustration purposes, I can show you how the keepers sit. So they kind of sit like so. So they create a wedge where this won't come off. So that's what you're trying to remove. If you are rebuilding a cylinder head and reusing the valves and the springs, make sure you keep them in the correct order that they were on the cylinder head. But since we are going to be replacing these and the spring itself, I don't need to concern myself with it too much. But like I said, I've always been in the habit of still just keeping it in order. Now the rest of the cylinder head, to remove all of these, is the same procedure. I'm going to put this on the back where it's going to sit on the valve itself. I'm going to compress it. Got my keepers. And release the pressure. It's a good idea to also inspect your valves when you're pulling them out. Even if you are replacing them, it gives you a good indication of the general health of the engine. You may find some carbon deposits on top of the valves, but what you're really specifically looking for is any damage around the seat of this valve. You're looking for any signs of cracks, which would have been maybe a possible cause of overheating, which would also lead to some compression and running issues. So you just want to take a good look at it and see the general condition. How is this engine running? Is there any abnormal amounts of deposits? Is there any damage to this valve face right here? And then conversely, also take a look at the actual seat where they seal. Make sure that you don't see any cracks. Everything looks to be in good condition. Just gives you a good indication of what's been going on with the engine. And right now, I mean, this one looks okay. So there's something else that a lot of people don't know. Maybe you have a crack on your valve seat or on the face. What a lot of people don't realize is as this engine is operating, and this goes true for all of these types of valve engines, as the valve is opening and closing, it's going to twist a little bit, just so slightly. It's going to keep moving and going back in and out, and moving. It's always got a twist. If it's not doing that, that could lead to some premature valve damage, excessive wear on the seats itself, and ultimately some bigger issues with it running and things like that. And most people will go, well, when does that actually rotate? Most of the time, your valve will actually rotate at higher RPMs, is when that really occurs, is that opening and closing. So, as in the way of all engines, when we say it's a good idea to beat on it once in a while, it really is a good idea to beat on it once in a while. Grandma that doesn't get her car up to over 2,000 RPMs and only goes to the church or the grocery store back and home, she's also not getting the engine warm, but she's not allowing the valves to spin. So any carbon that's built up on the valves, it's just going to keep sitting in the same spot because Grandma didn't let it go and warm up and twist around a little bit to move those valves. So it's very important just for general maintenance of your own engines, beat on it once in a while. Next thing we're going to do is I'm going to go ahead and remove the old valve seals that are down inside where the cylinder valve and the springs were and take all those out. We were provided new seals, and since I have it all apart, that'd be foolish not to replace them. These will keep oil from getting down into the cylinder and the combustion chamber and burning. Maybe you got a car that every time you start it up on a cold start, you get a big old puff of blue smoke that comes out the back. That's typically caused by bad valve seals, allowing oil to drip onto that cylinder, and the first time you fire it up, it's going to burn that out and send it right out the exhaust. Typically it clears up and you don't think too much of it. But that's an indication that you're possibly having some valve seal issues and they would need replaced. Too much of that oil leaking into there could cause damage to the valves themselves, and especially the people that don't drive a lot and allow their car to get warmed up to proper operating temperature and burn some of those deposits off. So I'm going to go ahead and remove those. I'm just going to use a pair of needle nose pliers and pull these right off the actual seats that they're on there. And we're going to throw those away and install some new ones after we do a little bit of valve lapping. So what we're going to do now is we're going to lap the new valves into the cylinder head where the old valve seats are. I'm going to first go ahead and doing a general cleanup of the actual surfaces right here, just clean it up a little bit. And then I'm going to show you how to lap the valves, because you need to lap the valves into the heads. We can't just take them out of the package and throw them in. We'll show you what that entails in just a moment after I clean this up and make sure that I have a good clean surface. I don't want any pieces of carbon or anything that may have fallen off during removal of the valves. I want to make sure that everything's nice and clean before I go through this process and wipe everything off thoroughly. This will also give you a really good chance to see what the valve seat looks like. Now that that's cleaned up, make sure, just take a quick inspection, do a look, make sure everything looks okay. Are there any cracks that would indicate some problems? If you had it cracked, you're probably going to have to send it out to a machine shop for possibly some repairs that they could do for you. But just taking a look, make sure everything looks okay. You can look at the valve seats and make sure everything looks all right. Everything looks pretty good on this. You'll also notice that these are two different size valves. So it's not too hard to mix them up, or it's relatively hard to mix them up, sorry. So in our rebuild kit, I got new intake valves, I've got new exhaust valves, I've got new springs, and I've got new seals. Everything I need to do the job except lapping compound, which I brought and have some of that in my own. It was my own, we all have some of that in our toolboxes possibly. So when you're looking at these heads, the smaller of your valves is your exhaust valve, And your bigger one is your intake valve. So you might be looking and going, wow, the top ones look dirty, but these ones don't. And there's a reason for that. The intake valves are only allowing air and a fuel vapor mixture to come through into the combustion chamber, sealing off, allowing the combustion process to occur. Now the exhaust valves are opening up, so they look a little dirtier because they're dealing with the residual leftover. All of your exhaust that's coming out of there, all that hot gases and everything else. So they take a little bit more of a beating during their operation, and definitely want to pay a little bit closer attention to the valve seats on these and on the surfaces of the valves. But even after a thorough inspection, which I've completed, they are in good shape. But if, just in case you were wondering, why does that one look dirty and that one looks so clean? Is that normal? It is absolutely normal. But I'm going to start with my exhaust valve right here as the first one that I'm going to lap. Now it's important to remember, once you lap this valve to this valve seat, it stays there. So just like I've said in the past, it is very important that everything stays together. So when this valve is mated to this, make sure you keep it in the correct order and don't mix them up. So you can see here's your surface area of the actual valve, and it's got a seal right in here. It seals when this is closed. It's got to have a perfect seal. When this is closed, this needs to be sealed. Anytime it can't seal, you're going to have some combustion or some compression issues, some running issues. So what's recommended now, since this is not used to this, we're going to kind of help it along. We're going to basically marry them together with the help of some lapping compound. You don't need a lot of lapping compound to do this. But I'll show you a couple tricks on how I do this and save you a little bit of time if you're doing this in the garage. You just put a little bit on the face. I'm not going crazy here. We don't need a lot. This is an abrasive material. So of course, when we are done, you need to make sure that you clean off any remnants of this on the actual valve seat or the valve face, and then of course the valve seat as well. So I'm going to put that in here. Now what this lapping compound is, again, it's an abrasive. We're going to move that cylinder valve, we're going to spin it and create a surface that they're both together on so that the old and the new kind of work together and do that. You'll see in some shop manuals, or you may have seen, there's a small suction cup device that you can use and run it back and forth to do that. I do a little bit of a different method. Seems to work well for me. Learned this trick years ago from an old timer that I used to work with. Great guy, and they always teach you a lot of great tricks that you don't find in the service manual. So what I've got here is just a vacuum tee, piece of vacuum hose, and a zip tie, just to create a little bit of a smaller diameter on here. I'm going to use this in my drill. I think you see where I'm going with this. But from back here, I can slide this right onto that valve. Here I'm kind of going back and forth too. I'm not just grinding it, I'm kind of going a little bit. And then once that's done, you can see that it went all the way around. And you'll also notice that that shiny new valve has a wear surface now. And that's a good thing. That's what we want. And inspect it too. Now that I've lapped it in, does it look like it's even, conformed? Does it look like it's right in the middle of that face? And boy, this looks like a great job of seating. The valve looks like it's going to be just fine on this seat. Again, we make sure take the time to carefully remove all traces of the lapping compound. We do not want that left on there when we fire it up. But you can see the difference now between this one that's been lapped in and the one that still hasn't been. You can see how they definitely line up well.